A tennis ball is hit with a racket from a point 1.5 meters above the floor. The ceiling is 8 meters above the floor as shown in the diagram. The initial velocity of the ball is 15 meters per second and the angle is given as 50 degrees. We have to figure out the mean force which is exerted by the racket on the ball if it is mentioned that the tennis ball was stationary before being hit. So the mass and the time of contact is also given. So how do we figure out the mean force? We will again use the impulse momentum theorem. J is equal to F delta T is equal to delta P. So let us try to make F as the subject. So we will get change in the momentum upon time. Now the time of contact is mentioned in the question as 23 milliseconds. So be careful. We are supposed to convert that into seconds. So the factor of 10 to the power minus 3 is very important. Now change in the momentum is m into final velocity minus initial velocity. Initial velocity is 0 since the tennis ball was stationary before it was hit. And the final velocity after the racket hits the tennis ball, the velocity is 15. So let us put all the values in. For change in the momentum, we will write m into v final minus v initial. Mass is 5.8. Let's write this down. 5.8 into 10 to the power minus 2 multiplied by final velocity is 15, initial velocity being 0, so 15 minus 0. And let's try to simplify this. In the numerator, we will write 5.8 into 10 to the power minus 15 into 15 divided by the time taken. And if we simplify this, we will get 37.826 newtons. And if we need to round this off to two significant figures, we can write down the force is approximately 38 newtons, correct to two significant figures. Now, in the second part of the question, we were supposed to explain how the Newton's third law is applicable when the racket hits the tennis ball. So, Newton's third law, we remember, is the action and reaction pair. Forces are always in pairs. So, if object A is exerting a force on object B, so object B will also exert the same force on A, but in the opposite direction. So, magnitude is the same, directions are opposite. So, how do you write that in statements? This is the official answer. So the second part of the question, how do we start? First, in the magnitude. So force of the ball on the racket, that is equal to the force of racket on the ball. And the value we had figured out was 38 Newton. So this was magnitude. Now the direction. The ball exerts a force in the opposite direction to the force of racket on the ball. In other words, let us draw a diagram. Let's say this is a racket and we have a ball. So if the racket is giving a force to the ball in the rightward direction, so the ball is going to provide a force, same force on the racket, but in the opposite direction. Remember in the Newton's third law, magnitude of forces are the same, direction are opposite, but most importantly, both forces act on different objects. Some students make this mistake of keeping both forces on the same object. That will violate the Newton's third law, which states that the two action reaction forces should be acting on different objects.